Assalamu alaikum. Bismillahirrahmanirrahim. University of the Punjab Associate Degree in Arts, Science and BA BSc Part 1 Annual Exam 2020. Subjects Mathematics B Course 1 Paper Vector Analysis and Mechanics. Time 3 hours, marks 100. Note: attempt 6 questions in all, selecting one question from section 1, 2 questions from section 2, 2 questions from section 3 and 1 question from section 4. Section 1. Question number 1. I, A, B, C are the vertices of a triangle, prove that A cross B plus B cross C plus C cross A is perpendicular to the triangle ABC. 2. Show that the 4 points A, B, C, D are coplanar if B, C, D plus C, A, D plus A, B, D is equal to A, B, C. Question number 2. 1. If UT is a unit vector, show that U dot U plus D square U over DT square plus DU over DT का whole square is equal to 1. 2. If R is equal to XI plus Yj plus Zk be a vector function, then show that divergence, gradient, R की power m is equal to m plus 1 or m minus 2. Section 2. Question number 3. 1. The resultant of two forces P and Q is of magnitude R. If Q is doubled, R is doubled. If Q is reversed, R is again doubled. Show that P square colon Q square colon R square is equal to 2:3:2. 2. Forces P, Q act at a point O and their resultant is R if any transversal cuts the lines of action of the forces in the points A, B, C respectively. Proof that P over OA plus Q over OB is equal to R over OC. Question number 4. 1. Find the force necessary just to support a heavy particle on an inclined plane of inclination infinity, where infinity greater than lambda. 2. A hemispherical shell rests on rough inclined plane whose angle of friction is lambda. Show that the inclination of the plane base to the horizontal cannot be greater than sine inverse 2 sine lambda. Question number 5. 1. A regular hexagon ABCDEF is composed of 6 equal heavy uniform rods jointed together and two opposite angles C and F are connected by a string which is horizontal, AB being in contact with the horizontal plane. A weight W dash is placed at the middle point of DE. If W be the weight of each rod, show that the tension of the string is 3W plus W dash over under root 3. 2. A rhombus ABCD is formed of 4 equal uniform rods freely jointed together and suspended from A. It is kept in position by a light rod joining the middle points of BC and CD. Semicolon. Proof that if T be the thrust in this rod and W the weight of the rhombus, then capital T is equal to W, tangent A over 2. Question number 6. 1. Find the center of gravity of uniform lamina forming a quadrant of an ellipse bounded its semi-axis. Page 1 of 2. Page turn over. 2. Find the center of gravity of the area bounded by the parabola y square is equal to 4ax, the axis of x and the lattice rectum. Section 3. Question number 7. 1. Find the tangential and normal components of the acceleration of a point describing the ellipse x square over a square plus y square over b square is equal to 1 with uniform speed v when the particle is at 0, b. 2. Apply the formula v square over p for normal acceleration to find the radius of curvature at the vertex of the parabola y square is equal to 4ax. Question number 8. 1. Find the equation of trajectory of a projectile. 2. Show that at any point P on the path of a projectile, the velocity and kinetic energy is the same as acquired by it in falling freely under gravity to P. From the point on the directrix y is equal to v naught square over 2g which is vertically above P. Question number 9.1. Show that the force F is equal to yzi plus zxj plus zyk, comma, acting on a particle is conservative and hence find the potential energy of the particle. 2. A particle of mass m moves under the influence of force F is equal to A sin omega t I plus cos omega tj if the particle is initially at the origin. Proof that work done up to time t is given by a square over m omega square 1 minus cos omega t, and that the instantaneous power applied is a square over m omega square sin omega t. Question number 10. 1. A particle starts with a velocity u and moves in a straight line. If it suffers a retardation equal to the square of the velocity, comma, find the distance traveled by the particle in time t. 2. A point describes simple harmonic motion in such a way that its velocity and acceleration at a point P are u and f respectively, and the corresponding quantities at another point q are v and g. Find the distance pq. Section 4. Question number 11. 1. A particle describing the curve Rn cos n theta is equal to a ki power n under a force towards the pole. Find the law of force. 2. The law of force is capital M u ki power 5 and a particle is projected from an apse at a distance a. Find the orbit when the velocity of projection is under root m over a square. Question number 12.1. A tennis ball is dropped from a point P at a height h, the surface of the court, and rebounds to a height h. Prove that the velocity small v with which it must be projected vertically downward from P in order that it may just return to P after rebound is given by hv square is equal to 2g capital H minus small h. Find the impulse at the point impact of with the court in the latter case. 2. Two elastic spheres impinge directly with equal and opposite velocities. Semicolon. Find the ratio of their masses so that one of them may be reduced to rest by the impact, comma, the coefficient of elasticity being E. Page 2 of 2.